Hello everyone, I'm Instructor Holland, and here are instructions on how to answer the questions in exercise 10. They should help you with answering the questions and back-working some as needed. The questions ask you to test the following arguments for validity, and they list, I think it's about 10 different argument types using sentential logic. For those that are invalid, specify the rows that demonstrate the invalidity. Okay, so I'm going to demonstrate how to solve test for validity for a simple question, and then I'll demonstrate how to test for validity for a more complex question. Okay, begin by reviewing the truth tables for negation and disjunction. Since negation just changes the truth value, this one is easy to remember. The table for disjunction is on page 129. Next, begin constructing the truth table for the argument. This will include columns for both P and Q to the far left. Truth distribution for the first column is half true and half false. Columns run up and down, rows run left to right. The last column ends with an oscillation, one true, one false, true, false, etc. Then place the premises and conclusion in right-hand columns. In this case, one column for the premise, not P, and one column for the conclusion, not P or Q. Next, plug in the truth values for negation and disjunction based on their truth values, on their truth tables, and the truth values for the terms in each row. Here you go. So for the first row, the negation of P, which is true, becomes false. The negation of P, which becomes true, is false in the second row for the first premise. The negation of false becomes true, and the negation of false becomes true. Similarly here, and then for disjunction, you just check to look for the truth value of disjunctions when the premises, when the terms are false, true, false, false, true, 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 false. It's these two here. Since this is here, and then this Q is here, you just look at the truth table for disjunction and plug in the truth value here based on the truth values of not P and Q. Okay? So to test for validity, then you just look at to see if there are any rows where the premise or premises are true and the conclusion false. If there are any, then the argument is invalid because the truth of the premises guarantees the truth of the conclusion in valid deductions. In this case, there are none, so the argument is valid. Okay, so now let's look at a complex question. Not P or R, not Q. If not Q, then not R, therefore P if and only if R. Okay, so to prepare, review the tables, the truth tables for negation, conditional, and the biconditional. Again, well, negation is fairly easy, so that one's really you're looking for disjunction, conditional, and biconditional. Pages 129, 130, and 132 in NACL. Next, begin constructing the truth table beginning with the terms P, Q, and R in the left-hand column. In the left-hand columns. Now notice that's 3 terms, so that's going to give you a greater range of truth value distribution in these columns. So you begin in the first column with a similar distribution as with 2 terms. You have half true and half false, and the last column always oscillates. So then you have to divide in between in the middle columns. In this case, it's this is half true and half false, half true, half false, and then that gets us to true, false, true, false, true, false, true, false. This covers all the distribution, the possible combinations of truth value for the different terms of the argument. Okay. Next, place the premises and conclusion of the argument in right-hand columns. Here we are. These 3, not P or R. If not Q, then not R. P if and only if R. Then plug in the truth values for the logical connectives using their truth tables, negation, disjunction, conditional, and biconditional, using the truth values of the terms in each row by row, as I had explained previously. So then you just plug in all the possible truth distributions here throughout this table. Finally, look for any row with true premises, true, true, and a false conclusion. If there are any, then the argument is invalid. And since, this is a mistake. Since there is one, there's one on row 5, the argument is invalid. And that's row 5. Sorry for the typo here, but I can easily change that. Here we go. Oh. Since there are some, the argument is invalid at row 5. Okay, well, so this is the method you want to use to approach both the simpler and complex questions, and it's algorithmic. It's really easy. It just takes time sometimes for the longer ones, but if you follow it right, just take your time with it, you'll always come to the same answers. So it's an algorithm. You just plug in the same data and you always get the same output, right? Same input leads the same output. Okay, well, that's the lecture, micro lecture on how to answer the questions for exercise 10. If you have any questions, please feel free to send me an email or stop by virtual office hours.